Okay, so now we're on log function properties. Went the wrong way. Wrong way. Oh, there we go. Log from function properties. So your log function is a little different, just like the exponential function, because the base can change. So your base is interchangeable, right? So this is just the general shape of what the log function looks like, but not a specified value. Okay. And again, that's because it changes. So for example, if b was to be equal to 10, then the x values would be 1/100, 1/10, 1/10, and 100. And then your y values would still be the same: -2, -1, 0, 1, and 2. Okay. Um, because this has a vertical asymptote, so I don't have a horizontal asymptote, I have a vertical asymptote. That means that my domain is dictated by my asymptote. Okay, so my domain depends on my asymptote. And notice here that it starts at 0, so it's from 0 to infinity. However, my range is going forever down and forever up, so my range is what's all real numbers. All right. So, talking about our transformation rules, domain and range, and all that good stuff. If you have the log base 3 of x plus 1, what are you saying is happening to your function? Like transformation wise. I'm going to go to the left one, right? Because I'm going to the left one, my vertical asymptote, so my vertical asymptote, that's at x equals 1, right? It's now going to shift, and it's now shifting to what? I'm sorry, x equals 0. Saw that. There we go. Equals -1. And because of that shift, that's what caused my domain to change. So, it'll be from -1 to infinity. Okay. Now, let's talk about how a square can impact your function. Okay. Normally, your logs can't have negative numbers, right? Can't have negative arguments. But if I'm squaring a negative, it now becomes a positive. So what happens is that your function can now exist with both. So you're essentially doing this, and you can also now have its negative counterparts. Okay. So you can have both now because of the squaring. Does that make sense? However, it still won't ever equal 0. So your function would be from -infinity to 0 because you have your left side and you have your right side, and that's what your new domain would be. Okay. The square allows you to have negatives because the output of those negatives are going to be positive. Okay. All right. So next are our log function rules that we have left. So here we have log base b of 1 equals 0. And that's just our 0 property. Anything to the 0 power is going to be 1, but it's the inverse of that, right? So the log of anything to the 1 is going to be 0. Next, we have our identity property. Our identity property is if your base and your argument are the same value, it's going to be 1. That's the identity rule. Okay. So we have our 0 property. We now have our identity rule. That T got weird. And then back to our good old power rule. But power here in this case really is irrelevant. It's because you're now looking at the base of your log and the base of your exponent. If they are the same, then the answer is just whatever your power is. Okay. And that goes along with the identity rule. So it's like the identity power or power of identity. I don't know how it's said. And then vice versa. If the base of your exponent and the log are the same, again, it's just going to be the argument instead of the power. Okay. So yeah, let's dive in. So starting off here, we have log base 7 pi. Pi, because the base of your log and your argument base are the same. So it's just going to be pi. It would just be 4x because the base of your exponent and the base of your log are the same. And then here again, even though it's a fraction, fractions are our friends, the rules still apply to them. It's just going to be 4.6. So do we see how the identity property works? Khan Academy. Yep. Go look at 4th grade Khan Academy. I'm not being funny, but that's where the main fraction stuff takes place. 4th and 5th grade. Yeah. All right. So we're going to solve one-step exponential problems using log. So up first, we have 10 to the x equals 10,000. Now let's just pretend that I didn't know what 10 to the x equals 10,000 was. What could I do? Well, I could take the log of both sides. However, this is one that we do not need to take the log of both sides because we simply understand what it's asking us, right? 10 to what power equals 10,000? And we know that to be 4, right? I can easily do it by just counting. I have 1, 2, 3, 4 zeros. So that means it would have to be 10 to the 4th power. Okay. This one, however, 125 is not a power of 10, is it? Nope. It is not a power of 10. So this is where we would have to use our log. So we're going to take the log of both sides. So we take the log of 10 to the x equals the log of 125. By taking the log and using our identity property, our 10 cancels out, and we're just left with x equals log of 125. So the exact value is log of 125. If I wanted the approximate value, then I would plug that in and get an approximate value. Okay, so what we did here is going to be the same thing that we have to do here because is there anything you can do with 1 minus pi? No. But before you do that, what is the value of pi, my friends? It's roughly 3.145 blah, 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 whatever. I'm just going to let it be. You know what it is. Okay. However, the premise here is 1 minus pi. Is that a positive or a negative? It's negative. So when I rewrite this, I'm going to have a negative argument. Does it make sense? So when I rewrite this, it becomes log of 10 to the x equals log of 1 minus pi. And this is negative. If your argument is negative, we said that in the very beginning, that means that you have no solution. There's no solution for that. Okay? So I wouldn't have to go any farther as long as I realize, hey, oh no, this is negative. So therefore, there is no solution. All right. Now, let's move on to a multi-step. Okay? Please have your calculators out and ready for someone to actually calculate because I don't know if I'll feel like typing. All right. So we have 4 times 10 to the 2x minus 3 plus 4 equals 16. The first thing that you have to do is get your exponent by itself. So in order to get your exponent by itself, what do I need to do? I do what? No. Minus 4. I'm going to subtract 4 first. When I subtract 4, I'm left with, that's not what I'm left with. Let's try that again. 4, 10 to the 2x minus 3 equals 12. Now what do? Now I divide by 4. When I divide by 4, I'm now left with 10 to the 2x minus 3 equals 3. And now we're taking the log. So I take the log on this side, and what does it do? Cancels out that, and I'm up with 2x minus 3 equals the log of 3. X is not by itself yet, so what do I need you to do to get x by itself? I'm going to be adding 3 and then divide by 2. So this is my exact value. X equals log 3. Make sure when you put in the calculator, you're protecting that 3 plus 3 divided by 2. And what is our approximate value? Because it's not the same thing. You're not taking the log of 6, you're taking the log of 3. Can you give me 3 decimal places? Just go up and hit it. Hit enter.
have an inspired. Give me a second.
Approximately 1.74 for my student who has changed her settings.
It can be better.
No, it doesn't. It doesn't automatically round. You have to make that a setting. All right. Was that terrible? Then practice is what you need. Okay. All right. Now, next word, a big word of the day. Exponentiate each side. Okay. That's what we're going to do when we're solving exponential and log problems when you have a log instead of an exponential. I don't think so. I don't think that's right. The actual 7 through 9? Yeah. I was like, wait, what are you saying? Once X is free, plug in the calculator. Okay. So here we go. We're gonna start off real simple with one steppers. Okay. So what you're looking at is what is the base of your log? What is the base of a log, even if you don't see it? 10. So this is base 10. So I'm going to exponentiate it to 10. And what I do to one side, I'm going to do to the other. What happens is it's going to cancel this out. So we're left with x equals 10 to the 2, which is what? 100. Okay. So again, our base is 10. Going to exponentiate. It's going to cancel this one out. And we're left with x equals 10 to the negative 1. What is 10 to the negative 1? If you said 1/10, you are correct. Okay. My power is negative, meaning that I am not happy with where I'm at. Okay. Last one again. My base is 10. So when I exponentiate, it's going to be to the 10. Okay. And now we get our x equals 10 to the 2/10. So this is my exact value. And I would use the calculator to get the approximate value. The other two did not require a calculator because they were following powers of 10, right? This one, not so much. So 10 to the 2/10 is what? 1.58. Okay, how do we feel about exponentiating? Okay, so we did our one-stepper. Now it's time for our multi-step. Again, the goal here is to get the log by itself. The log by itself. Pretend that I highlighted all that. Okay, what's the first thing to do to get the log by itself? Minus uno. So minus 1, and we're left with 1/2 log of 2 minus x equals 2. All right, what's next? Divide by 1/2, which is the same thing as doing what? Dividing by 1/2 is the same as multiplying by 2. So I can multiply both sides by 2. And we're left with log of 2 minus x equals 4. Okay, now this is where the exponentiating comes into play. No base means that this is 10. And I'm going to raise both sides to the 10. This cancels this out. So I'm left with 2 minus x equals 10 to the 4. What is 10 to the 4? 10,000. Now, what do I need to do to find x? Minus 2. So we get negative x equals 9,998. And then divide by negative 1. So x equals negative 9,908. They are never close. Okay. How do we feel about multi-step with exponentiating? Good. All right. Now we have 2 to the x. This time, our base is not 10, which is okay. But also, this is an example to show you that you have the math skills to do it without a calculator. Okay. When you are doing or trying to do it algebraically, or if it appears on the SAT non-calculator part, the goal here is to make your bases the same. So the first thing we're going to do is rewrite this as a exponent. So we have 2 to the x equals 16 to the negative 1. Okay. The second thing I'm going to do is change the base so that both have the base of 2. Okay. I can't change 2, but I can change 16. So 2 to what power equals 16? 4. So this becomes 2 to the 4 times negative 1. Okay. So once your bases are the same, all you're paying attention to are your powers. That's all that matters. So my bases are the same. So I'm asking myself, I'm telling myself x equals, and what's 4 times negative 1? Negative 4. Was that terrible? Okay. Now, if you chose to do it on the calculator, you would have to take the log base of 2 of both sides. Does that make sense? So I'd have to do the log base of 2. So it'll be log base 2 of 2 to the x equals log base 2 of 1/16. This is going to cancel out, and we get x equals, and this is what I'm plugging into the calculator. So in the calculator, I would plug in log base 2. On the TI-84, to get to change of log base, you're going to press the math button, and then you're going to scroll down to A, and it'll say log base. And that's how you would get to it. Okay? But guess what it's going to tell you the answer is? Negative 4. And we already did that, right? We already figured out that it was negative 4. All right. Next, we're going to look at an example of, oh no, what is this e? Okay. So we have 2 to the e to the 2 times e to the x equals 7. So with 2 times e to the x equal to 7, we're going to have to get the exponential by itself, the exponent by itself first. So what do I need to do to get this guy by itself? Divide by 2. Okay, that didn't work out so well. I thought I could pull it off and be smooth with it. It wasn't at all. Let's try that again. Divide by 2. Divide by 2. And we're left with e to the x equals 7/2. Okay? Because our we have e as our exponent, remember how I told you that natural log equals log base e. So in order to cancel out the e, we're actually going to take the natural log. So we're going to take the natural log of one side to cancel out the e. And what I do to one side, I have to do to the other. So this is my exact answer. And I would plug it into the calculator to find my approximate answer. And we get approximately 1.253. Okay. So do we see the difference between base 10, base 2, base E, base of anything? The main thing is with base E is the only time you're going to use natural log versus log. Okay. Now, I'm going to pause and give whoever is willing to try a moment to try on their own. I need a nap. May have to go make coffee. Because I'm definitely falling asleep. Oh, dang it. All right, friends, what do I do first? Plus 6. So we're left with 5. 3 to the x equals 30. Then what do? Then divide by 5. Cancel that bad boy out. And we're left with 3 to the x equals 6. Okay, how do I get the x by itself? It's going to be log base 3. So I'm going to cancel that out. And what I do one side, I have to do to the. So this is my exact. To find my approximate, I would have to plug it into the calculator.
Oh, 1.631.
Process. All right. Was it terrible? Oh, okay. Here. So on this one, we have log base 6, x equals 3. When I'm doing log, I'm going to exponentiate, right? And it has to be the same base. So it's going to be 6, 6 to the 3. Cancels out. So we get x equals 6 to the third power. X, 6 to the third power is 216. 36 times 6. Okay, so that one's a pretty easy one, right? Little one-stepper there. Okay, so on this one, it's another little one-stepper. What am I going to do? Exponentiate to what? 3. So it cancels out, and we're left with x equals 3 to the negative 4, which is what? Three times 3 is 1 over 81. Good job. Why is it 1 over 81? Because it's a negative power. Okay. All right. Or we have natural log of x equals 6.2. There we go. Exponentiate to the e. So I'm going to cancel out my natural log, and we're left with x equals e to the 6.2. Then you plug in the calculator to get the approximate value. Approximately e to the 6.2 is doable. Maybe. I know you don't want it to be, but it is. All right, got a little harder. Now what do I do? Before I can do anything, I gotta divide by the 6. You can't do anything to the log until it's by itself. So now we have log base 2, 3 times x equals 2. Now what can I do? Exponentiate. We can exponentiate, and it's going to be the 2. What I do to one side, I'm going to do to the. So we have 3x equals 2 to the 2, which is what? 4. So 3x equals 4. So what is x? 4 over 3, 4/3. You have to divide by your 3. Okay. So far, log and exponentials, were they bad? Awesome. That's it.